ETA to Abeam practice problem 5. Let's jump into it. ETA to Abeam of a lighthouse practice problem 5. Here we go. We're going to record all the information that the problem gives us. It's not even on this one. Let me go here. It's on this one. 5. You are steering 115 true. Here's our course. Course is equal to 115 degrees true. And a light is picked up dead ahead at a distance of 16.7 miles at 5:22. So it gives us our first distance. Distance equal to 16.7 nautical miles dead ahead. And we got that distance at 5:22. It gave us a time. Equals 5 hours and 22 minutes. You change course to pass the light 3.5 miles off Abeam to port. It gave us our second distance. It gave us our distance A distance Abeam, which is 3.5 nautical miles. To port. Told us they're at port. That's good. If you're making 12 knots, what's your ETA at that position? Okay, so it gave us a speed. 12 knots. What's a knot? It's a nautical mile per hour. We love units. They keep everything straight. ETA. What is your ETA? That's the question. Now let's make our triangle. What's our course? 115? Well, 90 is that way, right? 270 is that way. 115 is like somewhere along those lines. And it says we see it dead ahead. And then we want to leave this to port. So that means that our next course is going to be over here. And we're going to leave this thing, boom, just to port, which means that's 90 degrees. And it gave us two distances. Distance 1, 16.7 from our original course was 16.7 nautical miles, right? And then it gave us our second distance, which was 3.5 nautical miles. Okay. The hypotenuse is always C, and it's always going to be across from this 90. So we have this one C, we'll call this one A, and this one B. And we need to figure out this distance, B. So we use our Pythagorean theorem, which is A squared plus B squared equals C squared. We need to solve for B, so we subtract A from both sides. B squared equals C squared minus A squared. Good, we're set up. And now we get C. What's C? 16.7. 16.7 squared minus A, 3.5. 3.5 squared. Okay, I can't do either of those in my head. So let's get on this calculator and then we'll say 16.7 squared. 16.7, see that X, squared equals 278.89. 278.89 minus, what's 3.5 squared? 278.89, check. Clear. 3.5 squared equals 12.25. All right. 12.25, getting kind of close to the edge. So when we do that subtraction, what's that? Clear all that out. And we'll say 278.89, 278.89 minus 12.25, is that right? Equals 266.64. It equals 266.64. What equals this? B squared. Okay, now we need to get rid of that 2. So square root of both sides will get rid of that 2, and we'll be left with B equals square root of 266.64. Get under there. Okay, let's punch this into our calculator. And we can use our little trick here, right? So it's on the calculator. That means it's an answer. We go second square root second of our answer equals 16.33. 16.33 equals B. Does that make sense? Yeah, it does. 16.33. See how it's just a little bit shorter than C? This one, your B is always going to be a little bit shorter than C, meaning just from at a glance, that makes sense. So now that we have this distance, it's nautical miles, right? Boom, nautical miles. We love our units. So distance, speed, time. Distance is equal to 16.33 nautical miles. 16.33 nautical miles. Speed, what was our speed? Speed, 12 nautical miles per hour. 12 nautical miles per hour. Okay, time. How do we get time? Well, our little thing tells us, a little D Street thing, time is distance over speed. Good. Distance over speed. What's our distance? 16.33. 16.33 what? Nautical miles. Our speed is 12 nautical miles per hour. When we look at this, how many times is 12 going to 16? More than 1. So keep that in mind. What's that equal? Let's punch it. Okay, so this is already on there, right? And we're just dividing that by 12. Divided by, the ANS is what was just on there. 12 equals 1.36. So 1.36, these nautical miles cancel, hours. Okay, that's more than 1 hour. So this 1 is fine. We can add that 1 to our time. Where's our time? We could add that 1, so that's okay. But this 0.36, we need to take that 0.36 hours and make it into minutes. 60 minutes over 1 hour. So cancel off hours. What do we get? 0.36 is going to be 0.25 is 15. 0.5 is 30. It's going to be between there somewhere. Let me guess. 0.36 is like 20 something. The mental math is good to check because if you start dividing by 60 instead of timesing, your math is going to be way off. So let's check it out. 0.36 times 60. Okay, clear. 0.36 times 60 equals 21.6. So that rounds to 22 minutes. So this equals 22 minutes. Okay, so we have 1 hour and 22 minutes. And we need to add that to 522. So 522 plus 1 hour and 22 minutes equals, that's nice. 2 and 2 is 4. 2 and 2 is 4. 5 and 1 is 6. 644 is what we got for our ETA. 644. Let's see what the problem said. Oh, snap. I see that as an answer. 644. Let's double check. Oh, I guess it's right here. Yeah. See 5 right there? D. 644. Good. So after this one, you're going to have 2 to solve on your own. If you get confused on those two, just refer back to these because all the steps are the same. Sometimes the givens will be slightly organized differently, but don't let that throw you off. Just follow these steps and you'll get through those two practice problems, 6 and 7. Excellent.